Hello everyone, welcome to my channel. Today I have picked Move Zeros problem and it is marked as easy. And yeah, this is a really easy problem, but I wanted to solve it so that we can have more hands-on two-pointer approach. So we will be given an array and we have to pick non-zero elements. We have to keep non-zero elements at the first end and the rest of the zeros at the whatever zeros we have found, it will be shifted towards the last end. So there are multiple approaches to solve this problem. First approach we can take is that we can make a copy equivalent to the length of existing array, and we can simply loop over the given nums. Whatever non-zero elements we have found, we can insert those elements in the new copy array, and then in the end when we reach till the end we can simply put zeros to whatever indexes are left at the new copy of the array. So suppose in this case, if I have taken a new copy array, in this case, new copy array will have 1, 3, 12 initially, and when the nums array will reach till the end, then we can fill the rest of the indexes of new copy with 0 simply. So this is a simple brute force approach we can use, but in this case since we are making a copy, we are increasing the space complexity as well, and the time complexity is also going to be big O of n because we are looping through the given array. So we can move towards optimizing this solution. We are given this array and we can use two pointer approach. Okay, and in this two pointer approach we can pick one last non-zero index. I am picking this big name because just for the clarity, I'm not going to use this in the coding. So the last non-zero index we can pick, and we can initialize it as 0. So initially our last non-zero index we have found at 0. We assume that the last non-zero index we have is at the first, and then what we can do, we can loop through the array, whatever array we will be given, we can loop through it, and the first non-zero element we will find, whatever first non-zero element we will find, we will insert it at the first place, and then so we will keep inserting last whenever we will loop through the array and we will find a non-zero element, we will keep it at the last found non-zero index. So we know that so this last non-zero index signifies that up till this point we all of the elements we have in the array is non-zero. So suppose we have it and at 0, once we found 1, we will shift 1 towards 0th index, and we will increment this value. So let's quickly write this approach and then we will move towards the dry run of this solution. So we will take one more index. So this is why I am calling it two pointer approach, because we are maintaining pointers and we are marking the various checkpoints for our solution using these pointers. So in this case, what we will be having a condition as well, that if my current nums of current number that I am looping over, is it a non-zero element? If it is a non-zero element, then we will swap. We will just maybe insert as well. We will insert this non-zero element at this position. Okay. And we will keep this at this position, and we will simply, now what will happen, we will keep whatever non-zero element we have found. So we are maintaining two pointers because we don't know at what position we will find 0 and we will find non-zero element. So one element is there to recognize One index is there to recognize between zero and non-zero element, and the other index, which is last non-zero index, is going to ensure that up till this point whatever we have is a non-zero element, so we can have a non-zero element at this point and then we can move ahead. So we can move ahead with this pointer and we are ensuring, so basically we are maintaining the partition up till this point, up till last non-zero index, whatever, whenever at this position is going to ensure, and this position is going to create a boundary between zero and non-zero elements. We will see how this works later on. So let's quickly move towards running this solution, and then we will have more clarity on this. Firstly, uh, when our I equals to 0, when our I equals to 0, array of I is 0. So at this point, our last non-zero index is also 0 and last non-zero element is also 0. So there is no need to update any array, update this array, because there is no swapping. There is no swapping that's that has been done. So let me quickly write this as well, swapping, yes or not. If swapping, then we are going to update array, and if not swapping, then we are simply going to be as it is. Now, since this is not a non-zero element, what would happen? This condition, it will not enter in this condition, so swap is not going to happen. Now my I will move towards I will increment, and the next element is 1 as well. At first index we have found 1, so it will check whether my nums of I is not equals to 0. Obviously it is not equals to 0. So at this point we are going to put at 1 at 0th index. Okay, and also since we have swapped it, right? We have no, we haven't swapped. We have inserted. What we did at this point, we just did this. We have inserted 1 at 0th index. Okay, so you can say up till this point we have 1 0 3 12. So you can say that this is the last non-zero element. Up till this point we have 1, and we have the other array which is 1032. We have simply copied it here. Okay, now uh, our now I is going to increment in this next iteration, and at second index it will find 0. Again nothing is going to happen. So in the last iteration, at the last we have found a non-zero element as well, so we have copied it and then we will simply increment it. So at it currently the position of last non-zero index is 1 and the element at it is also 1. Now there is no need to swap, so we will simply pass this step. In the next iteration, I will be 3 and element at I is also 3. So it is non-zero obviously. So it will come inside this loop in this condition that okay, I have found one more non-zero element. So it will simply put 3 at first index. Now our updated array is 1 and 3 up till see how this is making the partition between, how non-zero last non-zero index is making the partition. So see, we that's why we are maintaining 2 pointers. In the next iteration I will move towards 4 and it will find 12, and obviously in after swapping the, no, this is not called swap, I'm sorry, this is going to be called insert. So we are doing the insert operation here. So after the nums of I is inserted at last non-zero index, then at this point I is going to increment, my last non-zero index is going to increment, and at second index we have also found at this point at fourth index we have found 12. So at second index we are going to show We have inserted 1 at 0, 3 at first index, and now it's time to insert 12 at third index. So 12 at, sorry, the third position and second index. So 12 would go, 12 would is going to come here. 1, 3, 12 is the updated array we have, and you can see we have left with last. Now my I, my at my I has, we have exhausted the total number of indexes through I, but we haven't completed our array. In this case, we know that up till last non-zero index, we mean that once we are good, like non-zero, non-zero index is at this point. So after this point, what we can do, we can simply start our loop, and now we are going to start with this one. We will be taking this as our checkpoint, and then we will move towards the end of the array, and whatever values are left, we will simply put 0 there. So this is how we can move zeros at the end. So this is one approach, and obviously its time complexity is going to be big O of n. But you notice we are using two pass. We are using two pass here. Like the approach we are using is two pass. First, let's quickly code this solution, and then we will come back and then optimize it a bit more. Okay. Let me quickly copy this and I will make some changes. So let me make it let non-zero ind. Fine, it's a bit smaller name. Let's non-zero ind be like this. We don't know length, so we'll have to compute it. So, okay, and since when our nums of I is going to be non-zero, we will be simply implementing it. And once we have reached till the end point, we will start from here. And we will start from non-zero index. We will have to compute the length. Now I'm going to compute the length. So length is computed, and now see, let's try to run this. Yeah, this has been accepted. Let's try to submit it. It's submitted as well. So this is very easy problem and easy solution. We can try to optimize a bit more. We can simply, what we can do, we can whenever in this scenario, what we are doing, we are maintaining just a last non-zero index, and in this case you can see we have to move the array in two pass. This is not going to in a good way when we have more zeros, because in that case, like, it is not, we can optimize a bit more and we can simply do it in one pass as well. In that case, what we can do, we can simply swap the zero and non-zero elements. Okay, so that is going that, and then we will be done in simply one pass. We can simply swap these elements, and this is going to be a very easy solution after that. So what I have done, I have done nothing, but I have simply swapped it. I have simply swapped. Whenever we find any non-zero element, we can swap it. Let's quickly see how this works. When we when we run it, like, let's see how the swapping works for more clarity. I'm sorry, I have Okay. Rest all of the things are going to be the same. It's just that whenever we encounter a non-zero element, we are going to swap it with zeroth index element. Yeah. So here, if you see, when at first point only we found a non-zero element, what we could have done, we could have simply swapped zero and non-zero. So at this point, when we found a non-zero element, after swapping, it would have looked like this only. Okay, and let's see what would happen when we at the second place when we found the element. So here we can simply at this point we have zero. You see, at first index we have zero, and at third index we have 3, so we could have simply swapped these values. So once instead of copying, we can simply swap it. We are simply doing the swap. So swapping is making the solution more easy, and we have updated array like this. And at this point we could have, like, when after swapping we would be left with 12 and then 0 0. So this would have been the array. I hope, and this is a very easy problem. I hope you guys have understood the problem. Kindly let me know in the comment section if you have any issue, or if I need to speed up the way I am trying to explain things, or maybe I would, if I need to slow down, please let me know. I will try to incorporate your suggestions in my teaching, in my way of teaching. And the solution is going to take only big O of n time complexity. So yeah, this is very easy problem. Please try at your end. Please try to run this problem. Thank you for watching my channel.